intro to all the things that are web-like, because apparently you guys like web. Why? Why? Who voted for web? Where's your hand if you voted for web?
I don't remember.
How do you not remember it? You,
I didn't vote, but I would have voted for web.
I hate you.
I love
Okay. All right. So web. Why do we care about web? So these are like, this is actually like in order for the European Union's Agency for Cybersecurity of like the most common attack vectors for cyber threats. You can see the first thing is malware. That's because like malware groups are really big right now because ransomware is a part of malware. You know, like everybody does ransomware. Like ransomware is like the new Prada or something. I don't know. Is that how this?
Good money.
The second most common is web-based attacks. That's because normally when people make websites, they're amateurs and they don't do it well enough. And then over here, the 10 common attack vectors. So, right, we're looking at things like poor encryption, ransomware, phishing, misconfigured devices, trust relationships, DDoS attacks, software vulnerabilities, compromised credentials, weak passwords, malicious employees. This one, so software vulnerabilities, compromised credentials, weak passwords, malicious employees, poor encryption, phishing, misconfigured devices, trust relationships, all of those can be done through a web platform in some way or form, right? So like these are super common attack vectors, and they can all be done through web in some way or form. So it's like why we care about web. Web is actually a pretty important tool when like you're doing active pen testing. So a lot of initial ground is gained through web exploits. So we're gonna do a quick aside really quick to talk about common terms and common applications and kind of understanding right, like what web is first to then understand how we can attack web. So front end, also known as client side, right? Everybody that's asleep, have you taken SY110 at least? You're in it, so you know what client side is. You're not though, right? So client side means like runs on your browser only. Okay. Server side means runs on a server that's hosting a website. Right. So when we talk about, you'll hear me say back end and front end a lot. These are development terms. Okay. So when you're a developer making a website or web application, you are either a front end developer or a back end developer, or you can be a full stack developer, which means you do both front end and back end. Okay. So when we're talking about front end, we're normally talking about the design element, the client side, right? So this is the JavaScript, this is the HTML, this is the Bootstrap, things that make the website look pretty, but also make things run on your browser, right? So these are like cookies and things like that. When we're talking about backend, we're talking about how things are handled on the server and handled there, right? So this is the backend development. This is like, you're not going to see this. This is going to be the code only running. This is PHP, this is the HTTP requests, okay? So like, this is the protocol. These are the requests that are being made. And then this is PHP, right? So PHP is a backend web programming language that integrates directly with HTML, okay? So you can write PHP code into HTML. You can write HTML into PHP code. It integrates very nicely. And it's probably the most popular and most common of all backend languages. Others include Python. Python has two web programming modules, Flask and Django. They're kind of a headache to use. And then there's also a server-side version of JavaScript called like Node.js. Okay. Other languages, of course, provide back-end web development, but again, it's kind of a hassle to use them because it's a secondary. It's like a secondary resource. It's a collateral duty of that programming language, right? So for Python, it's like a collateral duty of Python to do web programming. You can do it in Java. You can do it in C++. You can kind of do it in C. It's kind of weird. But like the main way that it's done is PHP because the language was built to do that. Okay. HTML, we've covered this before, but right, hypertext markup language. It is the markup language that denotes how things are displayed on a web page. JavaScript is a language that is written to run client-side scripts. Okay, so whenever you request a website, you will also request the script, the .js files that go along with it, and those will run on your client rather than running on the server. Okay, and then right? So we have cookies, right? Who knows what a cookie is?
Isn't it like kind of like some sort of information that's stored client side, so that way instead of having to enter it in over and over again, you can just like automatically input it?
Exactly, right? So it's just a client. It's some type of information that's stored on the client, right? And it could be anything really. You can store literally anything in there. But normally it's used to remember some type of information. Amazon carts are cookies. So Amazon doesn't hold the cookies. Your browser holds the cookies, right? So when you go browse back to Amazon, your client, your web browser will remember that cookie exists for that. It'll pull the cookie, okay? And be like, hey, Amazon, here's my cookie. This is what used to be in my cart, right? But Amazon doesn't know what's in your cart until you go back to their website. None of that information is stored on Amazon. It's a nice distributed system thing, but it also protects the privacy of the user. Yeah.
So would say like if you click save my password or something like that,
Yeah.
that'd be a cookie that's like even though it's stored on the server side, you still have to store it on the client side.
Save My Password is different. Save My Password is not cookies because it's stored in a web browser. Okay, so like whenever you like click Save My Password on Google Chrome, Firefox, etc., it stores it directly into the browser's data in an encrypted file. I could find everybody's like on your Windows computer. I can find exactly where your passwords are stored in your Firefox subfolder, right? It's going to be an encrypted file. It's protected, but I could find it and possibly decrypt it. Okay. Same thing on Linux. There's a place where all that information is stored. Does that make sense? But they're not cookies. Because cookies are
it's stored backend rather than front end.
No, it's not backend. It's still a client side thing. But a cookie is specific. Like cookies are specifically set when you go to a website. Like they don't set your username and password. That'd be super insecure.
Yeah.
Makes sense. Got it. And then session IDs are server side, right? So think, right, you have a website running. How are you going to handle a bunch of different requests coming from different people and all the things that they want to do? The way you do that is with session IDs. So everybody is assigned a different session ID based off their session ID. You can store a bunch of information in session IDs. So you can store like their access level and other things like that. And based off their session ID is what you do when they request information or things like that. That's how you handle multiple sessions at once. Right. So these are common web terms and common applications that are used in web development. These are the things we're going to be attacking. These are going to be the things that we want to destroy so that we can get around them. And then, of course, the pillars of cybersecurity that go along with them is what we want to circumvent and applications that we use to help that. Any questions so far? Yeah. All right. Cool. So some common web attacks, right? I promise there's more pictures. Like pictures come later, but I couldn't find certain pictures. So common web attacks, right? HTML injection. That's injecting code directly into a website, right? That markup language, and it somehow responds back with it, so you can see it actively displayed on the page. If there is an HTML injection, then that means you can do cross-site scripting. Cross-site scripting is actively putting in JavaScript code to do something that you want. Okay, so if you're able to put in HTML code, that means you can put in a script tag. Inside script tags, you can define JavaScript code, which means you can actively run JavaScript code on any client if it allows for an HTML injection. That, however, is not always helpful because it also requires like some type of backend exploit. Why would that be? Can anybody that's been paying attention explain to me why cross-site scripting still requires a backend exploit of some kind? Where does JavaScript run? On the client. What are we interacting with? On the client. So if we're interacting through the client, we're trying to exploit the server, which means we want to have that backend exploit that we can access through our front end. Right? Does that make sense, right? So we're going to use our front end exploit to also access a back end exploit that normally only a developer would be able to access. It's not always true when you're trying to be a criminal, right? So like this is in terms of like CTFing or like actively doing pen testing. If you're a criminal and you're trying to steal information, then it's fine for like your cross-site scripting to run on the client side, but it means you're actively you're gonna man in the middle of the connection between a user and the like web request that they have, and then you're gonna inject some code instead that will reach out to you and give you the information that like somebody types in or something like that. That's when you would want like a client side. Like when you actually want it to run on the client side is when you're trying to do probably something a lot more illegal or malicious than you have to. The next thing is SQL injections. So SQL, we'll talk about it when we get to like the actual SQL injection. But essentially, SQL is a database language, and we can inject SQL code to get what we want. We'll talk about that We'll talk about it in more depth when we actually cover the SQL injections. CSRF token forgery. So a lot of common web applications now use CSRF tokens to validate users. There are common attack vectors that are used to forge CSRF tokens to allow actually unencrypted users or unauthenticated users to authenticate to a website rather than using a password. We probably won't get too much into CSRF tokens right now or tomorrow, but I thought it was worth mentioning that these are exploits that are available. Yes.
Is that when like you could log in with the Google account?
Yeah.
So that's what it's doing, so that you don't have to make a separate account.
Yeah, they have types of CSRF tokens.
Okay.
Other web attacks are remote code execution, so we'll see an example of that later today as well. But essentially, the PHP code is like for some reason running a system command, and so you're able to actually like directly do it. That was a attack on Hack for Troops. If anybody did that one, or did you get to that level yet? No. So that was a attack. I think for the intermediate level was a remote code execution through the website. That was cool. Other things are bad configurations, old versions, different kinds of forgeries, falsifications, bad credentials, bad account, right? So the normal things that we look for, mistakes that other people make, is most of our exploits past those ones. Yes. So, common web tools. All right. So common web tools. First one, inspect element and developer tools. They're your best friend, right? So developer tools will show us the JavaScript that's running. It'll show us a console where we can actively interact with the JavaScript. It'll show cookies. Autosubmit.decatur.net. Two T's. So it can show you cookies. It can show you the code, right? Like the actual HTML, but it won't show you the PHP because PHP just renders the HTML and then sends it in the request, but it like doesn't actually display itself. But you can see the JavaScript. You can see the files that get loaded when you request a web page in like the network portion. Let's see. You can do some other things. Developer tools have saved my life many times. All right. Next thing is Burp Suite. Burp Suite is as it says, a suite of web attack tools. Okay, so it allows you to man in the middle web requests. You can use it to start a proxy, and so all your web requests will start going through Burp Suite so that you can actively modify the requests. You can also use Burp Suite to send automated attacks to like tamper with websites or see if they're vulnerable to those types of tampering. So Burp Suite is used for a lot of active reconnaissance, man in the middle requests, other things like that. It's more of an advanced tool, but it still can be helpful to like understand what's going on at a deeper level. Then the Python request library is helpful if you're trying to send basic requests. SQL map is pictured down here. It is a automated well, it's not always automated, but if you use the TAC wizard mode, it is an automated tool that can do SQL injections for you. So it's super helpful if like you've exhausted basically every SQL inject that you know by off your head and that you can research later, and instead you can use SQL map to see if there like is something that you're missing or you just didn't send something correctly. And then Metasploit will be used to attack bad servers, bad configurations, things like that, old versions and whatnot. And then W3 Schools. So if you don't know what W3 Schools is, it's a commonly used website to help teach like Python, C. It has like all kinds of things on there. It's particularly known for its web stuff, so it has HTML, PHP, JavaScript, all that kind of stuff on there. I use it all the time. It's super helpful, and probably one of the best tools that we know. Okay, so HTML injection and XSS. So HTML injection most likely means that there's an injection for JavaScript and we can do XSS, right? So what normally happens is we can add some kind of input, so it's like a form asking us for something, and then it echoes back what is typed. The key things you're looking for is, does it ignore the HTML tags that you give it? So normally I give like a U, the like a U like this, and then like hello. And if what comes out is hello underline, then I know it's vulnerable to HTML injection. But if it keeps this or gets rid of it, I know it's somehow cleaning my input or not actually running it. So of course, to be vulnerable to XSS, it must be vulnerable to HTML injections. But with JavaScript, we can make server-side requests and return that data to our JavaScript function. However, there has to be some type of backend vulnerability or some type of backend page that we're trying to access. So for the example, I'm going to show you like the actual XML request. Can you not log in? Oh, I can log in. One momento. Only 8 stars. The other, yeah. 97. Yeah, what's up?
So so say that like you were given like a form to fill out that like somehow allowed HTML into the form. Could you just make like a loop that didn't end insert into the form? Like for like an input? Does that make sense? Like say it's like you made like a while loop that wasn't that would never reach the target value. Like would that just like produce like an infinite like an infinite?
Yeah, but you got to think about where that runs, right? So where's it going to run?
Client side?
Yeah, so it's just going to freeze your computer.
Oh.
Right? So
that'd just be bad for yourself.
yeah, that'd just be bad for yourself. All right, we're going to talk about I can't spell. Alright, I'm going to talk about these. Okay, so these are how we like take advantage of a server-side vulnerability. So they're XML HTTP requests, which means you can request something from the server and get a response back. Okay, so we can send a GET request or a POST request to the server and get information back from them, and use that information to gain some type of foothold. Okay, so like say there's like a run.php that we normally can't access. through the website, but we can, for some reason, access it through a JavaScript request. Okay, like we can send it the GET request that we want and send it the information that we want it to run, and then it'll do it. Does that make sense? Right. So this is the XML framework that we use. This was actually a problem. This was one of the intermediate problems on Hack for Troops, actually. Devin's the one that solved that one. It was pretty cool. It was a lot of work though. Okay. I would have had an example up of how to do what actual HTTP requests work, or what a HTML injection looks like, but then General Raymond came, so I didn't have time. My apologies. Yes.
So sometimes you can have like a GET request, and it won't have to go to the server to get that information. And then there's other stuff you can send a GET request, and it has to go to the server.
GET requests will always have to go to the server.
Okay.
Right. So the point of request is they always reach out to the server every single time. Are you thinking about like the Wireshark stuff? So okay, so I guess I kind of misspoke, right? So like when I say like GET requests always go to the server, that's like a GET request from a GET request from a client, right?
Right.
The response to the GET request will be sent back, but like in Wireshark or something, it's still labeled as GET.
Okay.
But it's a response to the GET request, so it'll have like a response code of 200.
Gotcha. Makes sense.
Cade, here.
Appreciate you.
Yeah. All right. Any questions? Any other questions before we move on? Anything.
So if you send like any GET request, right?
Any GET request.
And you figure out how to like what that path was, maybe, then you can figure out how to get into that server.
Yeah.
Okay.
Web is super dynamic and super like variable. Okay, like there's never a cookie cutter way to do it. A lot of things are like cookie cutter. So right, let me think of like cryptology. Right, there's one algorithm. There's multiple ways to break that algorithm, but normally it's pretty clear what the way is because it's clear what the vulnerability is. Web, it's not, because web, half the code is hidden from you because you don't know what the server side looks like, right? You can only see like what's up front. So there's a lot of like research that has to be done on the attacker's part to kind of see what must be done. Like to see like, hey, like I have this web page. I think it might be this. It could not be this. Cyber Red Zone, there was a web page. It was vulnerable to an HTML injection, which meant it was vulnerable to XSS, and they were using WebSockets. So we were trying to we were trying to have it like, we were trying to use the WebSockets to like read more information than we could. It ended up not being that at all. It was a completely different exploit, had zero things to do with HTML and XSS. But like, that's kind of web. Like web is just super variable, and like you never know what you're going to get, which kind of sucks. But it's just like the nature of the problem. All right. SQL injections. All right. Anybody know what SQL is without looking at my slide? Don't look at it. Don't look at it. Anybody know? Okay.
Wasn't it the thing you showed us like the first day?
Yeah. Actually, the first day I did show a SQL injection. That's right. Yeah.
I don't know what it was.
It seemed cool though, right?
It's-
Yeah, it seemed cool at the time, and then you started the team, and you were like, "Man, I really hate this dude, Christian."
You're sorry. That's exactly what I
Yeah, I know. So, what even is SQL? SQL stands for Structured Query Language. So, I think SQL is like super weird because normally, like, there's like languages that are developed around different things, but like SQL is a language, and then applications are developed around SQL. So basically almost every database uses SQL, the syntax of SQL, to do things, right? So SQL, you write specific like commands, and then it does an action. The way it does it, or the platform that you do it through, is based off of the application that you're using or the type of database, right? But everything is SQL. It's a very interesting I think it's a super interesting thing because you don't really see that very often. So common databases that take SQL code and then run them are MariaDB, MySQL, which is like probably the most common one, SQLite, and AccessDB. AccessDB is Microsoft's database, right? Their database system uses MySQL. Like AWS's SQL database also uses SQL based off the fact that SQL is in its name. SQLite is like a lighter version of SQL. Normally, when you run like MySQL or something, you're running on you have a SQL server running. SQLite allows you to do SQL databases, but in files. It's super cool. And it's pretty common in a lot of our problems. So right here is a common SQL query in PHP. So in PHP, you straight up just call a query, and then you put what you want to query in there, okay? So you can imagine for like a password check or for a username check, it's just going to straight up do a select and then the username here. So it's going to throw in a variable and then say from users, right? So the way the queries work is it says select. Select means I want to access something in this database, okay? And then it's going to say this is what I want to access, the name. This star is going to be like some type of name, the thing that you want to access. Star, what is star normally? Huh? In Bash, when we use star, what is it? Like in shell command line?
That's cool.
Huh? Wildcard, right? It could be anything. So we're saying get everything from, and then the database is the next thing after the from. So we're saying select everything from the person's database. So you can imagine that a password validation would be like select and then it insert the password from passwords. And if that fails, then we know they're not a real user, right? So what's cool about that is if they write their PHP badly and they don't validate our input, instead of putting in a password, we can just put in our own SQL code, okay? And if you remember anything from the first day, and I have an actual example of this one, or if you remember anything about coding at all, when you do an OR, right, and then do a 1 equal 1, this will always evaluate to true. So we can input gibberish over here with a quote, okay? So this quote's gonna break the query's quote. Now we're gonna put in our own code, okay? And we're gonna have some type of gibberish, and then we're gonna say or 1 equals 1. So now instead of it being select star from persons, it's gonna be select or 1 equals 1 from persons, okay? And it's always gonna evaluate to true no matter what. And then what we normally do is instead of putting this in the password field, we can put it in the username field. That way we don't have to guess the username. We can just do anything. And so you can put a tac or a // or I think a curly brace is the other one. These are the 3 most common types of comments in SQL. So we're going to put in some type of SQL code. Then we're going to put a comment out the rest of the query. Because normally the way the queries are written is it's a check for the username, and then it has an and a check for the password. So now we're just checking for the username and commenting out the check for the password, and it'll automatically authenticate us. Right? So these are the types of SQL injections that we can do. And I'll show like an actual SQL injection, and I'll also show you where to find SQL injections and kind of read about them more. So we're gonna do SQL. This one, I think.
It's such a funny thing with the 600 one too, because we like had 2 guesses where like it's either gonna be like this number or this number. It was the second one we put in there.
Yeah, that's fine. Okay, so I'm an official sponsor of Wikipedia. I love Wikipedia. Wikipedia is great. Wikipedia is life. If you look up Wikipedia and you can already there. No, not that one. Wikipedia SQL injection. If you look up Wikipedia SQL injection page, it is basically like the greatest thing on the face of the planet because you can scroll down and it'll show you like the most common SQL injections and it'll also show you like why these work. So, for example, here you see it's doing the select star from users where name is equal to something. And then it's like, oh, it's this username that the user's putting in, right? So like the username is coming from a form that the user has, right? Because, okay, so instead, what we put in for the username is one of these things, and it instead becomes select star from users where name is equal to blank or 1 equals 1. It's like, oh, okay, well, 1 equals 1, I know that. This could be false, but 1 equals 1, so it's cool. Right?
Yeah, we needed atomic stuff, but like, we wanted to like work with it.
So these are like actual like things you could just plug into there. Another thing, and once you start getting like better at SQL, you can look up SQL syntax and stuff. You can start like removing databases, right? You can start adding databases. You could query from databases. So what we've done before is we queried all the users and all their passwords from the database using a like login form, right? And then you can take all the database hashes and use some tool to break their hashes and then log in to some other type of service or to that.
When you query like one of the databases, where does that like go? Like, would that just put it out? Where
It returns it back to you.
just like in the form or like
It'll just print it out on the webpage.
just press it out?
Yeah. It's pretty dumb. Like they're not because it's just like it's like sending back the response to your webpage.
Okay.
So like it's gonna echo it back. And so like it just like so happens that it like writes it at the end of the response from the web server. So we'll see how this one works. Let's see if that works. Nope, that didn't work. Let's see what happens when we just put in that and then another single quote for that. No, that didn't work. How about that? No, that didn't work. How about that? No, that didn't work. So like I've thrown a couple things at it. I'm like, this doesn't work. I know it's a SQL injection, so let's kind of look at it. It seems to be that like the source of the page is just a simple username, password, right? So I know it's just sending it the username, password. It must be some type of SQL inject though. Yeah. So we're just gonna keep throwing things at it until it kind of works. And this is basically most of web, which is kind of sad, but just how it goes. So right, it could be a different comment scheme. So it could be like one of these. Could be the problem. So we try that and see if it does it. And you see that it throws this error. Bad web programming is printing errors client side. That's horrible web programming. And if it's printing errors to the client, that's normally your exploit, right? That normally indicates that like you're on the right track. Okay. So you can see you have an error in your SQL syntax. Check the manual that corresponds to your MySQL Server version. So now we know it's running MySQL. We know for a fact it's doing a SQL query. It says for the right syntax to use near / and password like at line 1. So we know it's doing like this and then the password like is something. So we've garnered some type of information from this. So we know what the query looks like. So what I believe we're supposed to do is something like this. I think it's like this. That's no. Okay. I think. And then there. No. So we see it has another problem with it. It doesn't like that. Didn't like that. I know the way to do it. I just forgot. Oh, I think I know. One. I do this one like at least 4 times a year, and then I forget every single time I do it, which is ridiculous because you'd think I would remember how to do it. Huh?
This is like a caption.
This is our CCFD.
This is ours.
Yeah. One second. I don't know if it's that one that's broken or this one.
Yeah, I was in 16.
No, it's definitely not that one. It's this one. How am I
That
not?
was bad. I looked the same job.
See you, sorry.
No, you're good. You're good.
Did I do it? Yeah. You did it. The one thing that I didn't fully understand was the file. You could open file. I don't know. As basically.
Okay. Did you? Yeah. Let's do it.
It's not.
I'm like a little over half.
Who do you have?
Edward.
All right, there is a way to do it. I'm just blanking on it, but I promise there's a solve because you saw me do it at the beginning of the year.
Right.
Because this was literally the exact challenge. So I don't know why it's not working, but it's not. Probably because I'm dumb. So
You're not done, Christian.
yes, I am. But that's the point. All right, that's SQL injections. I wish I was better at doing them. More examples. Not of the SQL injections of separate things. I promise. One of my favorite ones is this one, ping pong. Okay. I love ping pong.
I'm a beast at ping pong.
Are you? All right. So what's this say? What's this want? Okay. So what should we ping?
That's it.
Okay. 127. 127.0.0.1. Also, is this like an offset? What is this? What's going on here? Do you see this, right?
I see that.
Why is this way?
I don't know.
Why are you the way that you are? Anyways. Yeah, so what's this look like?
Okay, so
I don't get how to like ping pong.
I don't really know.
Okay.
Log entries.
Did we just ping it? Does look like
It looks like the output of something, right?
like we pinged.
Looks like the output of the ping command, right?
Yeah.
Okay.
That's
So
exactly the way.
keep saying it. What were you saying?
It's like a command line thing, right?
Yeah. So it looks like it's just running command straight up, right? Okay. So what does that mean?
Okay, shut down.
We want flags here. We don't want to break things. Okay. Don't break my systems, or I will kill you.
Did you know it was a command line thing? What was like immediately like?
Show direct.
Then when I ping 8.8.8.8, it does that, and that's exactly what that looked like.
So the fact that
It looks like the output of a ping command makes me think that it's probably just running the ping command.
printing whatever the okay. Cool.
You like LS then?
Okay. So just like type ls in here.
Yeah. Oh, wait, wasn't that ping LS? That wouldn't make sense.
Okay. Okay. So ping ls doesn't work. So what do I have to do?
So you have to find a way to get around the ping. So it doesn't get pinged.
Okay. What's a way of running multiple commands on the same line?
Whatever it's called.
But piping would be piping the output of one command to another command. How do I run 2 commands or 3 commands or basically infinite commands all in one line that have nothing to do with each other? Huh? Semicolon. Hell yeah. Okay, so I'm gonna put in the address. Okay. I'm a semicolon because semicolon says, okay, I'm done with this command. Now let me execute another command. I'm gonna type in ls. Okay. And so now it seems as if we have information. Like, right, that's the output of the ls command is just one page, index.php. So it looks like we have to go on a hunt for this. Okay. What's an easy way to find? We're gonna assume that it probably says flag. Okay. We're gonna go ahead and make that assumption. That's a good assumption to make when we're doing CTS. That the flag is normally called flag. Okay. So, how do I find a file in the entirety of the file system?
Find or grep.
Okay, so grep would find some type of input in our output. We're gonna use grep, but we'll want to start with find. Okay, so find. Where do I want to start looking?
Flag. All.
The first command to find is the first argument to flag is gonna be where do we want to start looking? Index. I mean, we could do tilde, but what if I want to look through the whole file system? God, this is a Linux system, man. What is wrong with this? Tilde is home directory. Root is what? / Okay, and then I want to look for a flag name, for a file name, flag. Okay, and then I want to send that to grep. How do I do that? Pipe. Ah, sorry. Wait, what did I just do? Okay, pipe. Okay, to grep, right? Flag. And then we're gonna hope that it runs. And it does, kind of. And does anybody see the flag?
Yeah, I can't read this.
I could also just do this for you too.
Go flag dot.
Yeah, is it that?
Okay. So where's that at?
It's in TMP.
Which is temp, right? That's the temp directory. You say CD in there?
Oh, I guess you can check like
Well, I'm gonna do this to prove a point. So CD into temp, right? Is what you suggested. I don't feel bad about this because I did this my first time too. What did I do? No, it doesn't matter. I can CD into it all day long, but this isn't the terminal. So I'm only seeing the output of my command. CD doesn't give me output. It changes the directory, but then it resets it. Right? So like subshells, when you ever use CD and stuff, but you're only getting output back, like CD is useless.
I am CD.
You are not useless. So yeah, we'll go with your correction, which is to cat /flag.txt. And then boom, the flag. It is there. And then we're happy. And then we think to ourselves, curse Christian, curse web. I hate it. I don't know why I wanted it. We crush Christian's dreams. Alright. So I suggest now that you go on to go do some web challenges on CTFD for the next 30 minutes. 15 minutes. Yes.
Can I get an account?
No. Yeah.
Hi, I'm John. It's my first day.
Hey, John.